Welcome to World Wood Day Fire in the West. My name is Steve Ambrose, and I'm a retired Forest Service employee as well as a volunteer for the International Wood Culture Society, who sponsors World Wood Day. The International Wood Culture Society brings people together to discuss wood and wood culture. In the past few decades, wildfire in the West has become an increasing problem, both for the West and for all of the United States. It causes destruction of not only our forests and our forest resources, but life and property as well. If you look at this graph, you can see that the number of fires in the last few decades has actually decreased, but the severity and the number of acres burned has increased exponentially. In cooperation with the Rocky Mountain Research Station, the International Wood Culture Society is developing a series of videos to help explain what is happening to fire in the West. Let me introduce our panel. Jessica Brewen is the Science Delivery and Public Affairs Specialist for the Rocky Mountain Research Station. Momo Shaw is the Video Editor and Program Coordinator for the International Wood Culture Society. Today we have invited Dr. Sean Parks to talk about fire history in the West. Sean is a research ecologist for the U.S. Forest Service, Rocky Mountain Research Station, and works in Missoula, Montana. He received his PhD from the University of Montana in 2014, specializing in forestry. Sean is affiliated with the Aldo Leopold Wilderness Research Institute and works on a range of 4 broad topics, including wildland fire as a fuels treatment, climate and fire regimes, fire facilitation from forested land to non-forested land, and evaluating landscape under a warming climate. Sean, thanks so much for joining us today.
Thank you, Steve. I'm really excited to talk to you and everybody else about fire in the West. Specifically, I'm going to be talking about changing fire regimes in Western U.S. forests. I want to quickly start off and state that this talk is geared towards forests only and Western U.S. only. Some of the lessons learned and some of the topics I'm going to discuss are not really transferable to other types of vegetation like shrubs and grass and aren't necessarily transferable to other parts of the world. So let's get started. So a lot of you are aware that we've seen an increase in area burned in Western U.S. landscapes. And here are 3 plots basically showing how area burned on an annual basis has been increasing in most Western U.S. ecoregions since, say, the 1970s or the 1980s. And this trend is apparent in a lot of studies. Here's another rendition of it where we see increases in area burned since 1985, and we've seen a 6-fold increase in area burned in forests since 1985. And we've also seen an 8-fold increase in area burned at high severity since 1985. I do want to highlight this at high severity piece right here, because I'm going to be talking about high severity fire a lot. When I'm talking about high severity fire, I'm talking about fire that burns all or most trees in a forest. And that's as opposed to, say, a low severity fire, which kills less trees or doesn't kill any trees in a forest. I will also use the term stand replacing fire. So stand replacing fire and high severity fire are the exact same thing. And just to reiterate, those types of fires are the types of fires that kill all or most trees at a given site or in a forest. I'm showing you these increases in area burned and area burned at high severity over the last few decades. But a lot of people often ask about just the natural drought cycles of the world and how the natural drought cycles are playing into what we're seeing in terms of fire. So I want to touch base on that real quick. And it's true, over time, we actually see a lot of variation in drought. And here's a plot at the top that shows that 0 is your average conditions. And when these lines go above 0, it means they're wetter than average. And below 0 means it's drier than average. So yeah, we do see a lot of variability over the last 1,200 years. And in fact, this drought in the late 1500s has been coined a mega drought. And the current drought we're having in the Western US is nearing that drought in the late 1500s. The current 19-year time span from 2000 to 2018 is the driest 19-year time span since the late 1500s. But what's important here is that these scientists have included that this current drought we're having, about half of its severity is related to human-caused climate change. So we would be in a drought anyway, that's correct, but the drought we're having is going to last longer and is going to be more severe because of human-caused climate change. And the same thing goes with fire. Because we are in a natural drought, we would see increases in area burned because of the drought we would be having. But this drought is amplified by human-caused climate change. And these scientists have shown that about half of the increases in area burned are attributable to human-caused climate change, and the other half are attributable to the natural drought cycle. Nevertheless, warmer and drier fire seasons are associated with more area burned. And so as we are expecting to see warmer and drier fire seasons in the future, we can expect to see more area burned. And I want to highlight the year 2020 here as a good example. So in this plot, it's showing the year 2020 in black, okay? And this vertical axis is showing wildfire area burned for each year. Each of these dots here represents a different year. And this axis here, the horizontal axis, is a metric of fire season climate. Above zero means it's warmer and drier than average. Below zero means it's cooler and wetter than average. So in 2020, we saw a huge amount of fire, more fire than we've seen at any time since 1984. It's also an outlier in terms of climate, as you can see. Here's another rendition of climate. We can show temperature on the vertical axis and atmospheric dryness on the horizontal axis here. Each of these black dots shows the climate from 1986 to 2015, and there's 2020 in the red. So you can see 2020 is an extreme year in terms of both fire and in terms of its fire season climate. And when we look into the future, it's a little concerning, in my opinion, because we see that 2020 is the new normal, more or less. Each of these black dots here represents our future climate under a global increase in 2 degrees Celsius. And again, the red dot shows 2020. So if 2020 is our new normal, and we think that 2020 is an extreme fire year in terms of area burned, we might be seeing a lot more area burned in the future. And that's something that we need to prepare for and be ready for. So I'm showing you this climate. I'm showing you current climate conditions and current fire conditions. But I do want to take a step back in time and take a longer term perspective at fire and look back over the last 600 years. And this is a fairly complicated plot, so I do want to walk everyone through it, but I think it's interesting and I think it's important. The red line here is showing a relative amount of fire through time since the year 1400. This black dotted line behind it is showing how climate varies over the last 600 years. So above zero, again, is going to be warmer than average and more fire than average. And below zero is going to be less fire than average and cooler than average. And you can see that there's a fairly tight relationship between fire, again shown in red, and between climate with the black dotted line. And we could actually see some fairly important climate events in this plot. We have the medieval warming period and the Little Ice Age. In the medieval warming period, of course, it was warmer, and we saw more fire, as shown by the red line. In the Little Ice Age, it was, of course, cooler, and we saw a lot less fire. But what's really fascinating here is that tight relationship between fire and climate becomes decoupled right here. This isn't about the late 1800s, and this has been dubbed the fire deficit. This fire deficit is incredibly important, and I do want to talk to you all about why this happened. And well, what happened, why there's a fire deficit now, and probably most importantly, why does it matter? Why does it matter that there's a fire deficit? So again, the climate has continued to warm, but the amount of fire we've seen has tanked. So I think one of the take-home messages here is even though we think we're seeing a lot of fire, and we are seeing a lot of fire in the Western US, it's actually a lot less fire than we might expect under these historical conditions when climate and fire were coupled. So what happened? Again, this point is about the late 1880s. And what happened was that's prior to European American colonization of the Western US. And that occurred right about in the 1880s, or the effects of it from a fire perspective really started to unfold or manifest in the late 1880s. So prior to the late 1880s, there was a lot of intentional burning by indigenous peoples or Native Americans. People started fires for a variety of reasons, from improving game habitat or to improve habitat for food. There's also lightning ignited fires were not suppressed. So if lightning ignited a fire, it just burned. However, after about the 1880s, or after European American colonization of the Western US, for the most part, most intentional burnings ceased. So people were no longer purposely igniting fires on the landscape. And also there's been a great effort to put out all or most fires, and that's called fire suppression. So again, we're seeing a lot less fire than we might expect given our warming climate. So what gives? Because on one hand, I'm saying, hey, there's a fire deficit. There's a lot less fire than we might expect given the climate. And on the other hand, I'm saying, oh, look, we're seeing more fire burning as a result of warmer and drier conditions associated with climate change. These things seem a little contradictory. So how do we explain this? Well, my explanation is that just the warming and drying climate that we're seeing is making it more and more difficult for us as humans to put out the fires. And so we're seeing our fire suppression is becoming less effective and more fires are burning just because we can't put them out. It's incredibly difficult to put out fires in hot and dry conditions, and we're seeing more and more of that as the climate is changing. So I do want to get into why it matters, why this fire deficit matters. So I'm going to move on to definition or a key concept here called the fire regime. A fire regime is a set of recurring conditions of fire that are characteristic of a given ecosystem. So it's not characterizing a certain fire or a specific fire. It's characterizing lots of fires over time for different ecosystems. And the most important characteristics of the fire regime are fire severity and fire frequency. And again, just to reiterate, when I'm talking about fire severity, I'm talking about the amount of trees that are basically killed during a fire. A high severity fire kills most of the trees or all of the trees, and lower severity fires kill less trees. Fire frequency and fire severity, these fire regime components or characteristics can be mapped, and they have been mapped. So here's a map of the fire regime of the Western US. And I'm calling this past fire regimes because I'm going to argue that some of these fire regimes are no longer existing. The light green area is showing are the fires that occur frequently or occurred frequently, but were fairly low severity, meaning they didn't kill many of the trees. In contrast, we have the standard placing fire that I've been talking about. The standard placing fires occur much less frequently, but again, kill most or all of the trees. These ecosystems tend to be colder and wetter forests. And I didn't mention this before, I guess I can go back. This fire regime, the low severity fire that is very frequent, tends to be warm and dry forests. So we've got basically two ends of a spectrum, the warm and dry forests and the cold and wet forests. And the dry forests, again, have low severity fire that's very frequent, and the cold and moist forests have high severity fire that's very infrequent. And let me just show you some photos of what this looks like. So in the dry conifer forests, it's very open, large trees, sparse understory, not much vegetation on the ground, and the fires tend to burn like this on the surface. And this is our frequent fire, low severity fire regime. On the other end of the spectrum, we have the cold and moist forests that tend to burn at high severity, but much less frequently. So I'm going to hone in again on the fire deficit, and I want to talk about dry conifer forests. So I'm not sure how many people are familiar with this photo on the left indicates, so I'm going to walk you through it. But these little tick marks in this tree, this is a tree that's been cut, and you can see the tree rings here, and you can see the bark on the outer edge. Each of these tick marks in the tree is called a fire scar. So historically, in dry conifer forests, as I mentioned, they had frequent low severity fire that didn't kill many of the trees, but the fires did damage the trees and left a mark on the trees. And these marks are called fire scars. And that's how we're able to understand that historically we had frequent low severity fire through this fire scar record. And this pattern of frequent fire prior to the 1880s is remarkably repeated by many scientific studies across the Western US. On the right here, each of these horizontal lines represents a different site that was sampled through fire scars. Each of the vertical ticks represents a fire scar. You can see again that there's been a lot of fire through time, and then in the late 1800s, fire gets turned off. And that's going to be, again, our fire deficit. I do want to touch on why this matters. The frequent low severity fire in these forest types basically maintained open conditions. They made sure that the forest didn't accumulate too much biomass. My analogy about these frequent fires is mowing a lawn, that every time you mow the lawn, you keep the lawn kind of low and trim and looking nice. So these frequent low severity fires are basically mowing the forest lawn. And if you stop mowing your lawn, say for the entire summer, your grass gets out of control and there's a big weedy mess, a lot of biomass out there. And so the same thing can happen here. When you turn the fires off or stop mowing the lawn or stop mowing the forest lawn, we start to get conditions that are becoming a little bit out of control, I guess, from a biomass perspective. So historically, we had these big, we had large trees and open conditions. And once you turn the fire off, you get a lot of growth occurring. And the more and more growth you have, the worse your inevitable fire is going to be. And let me show an example of that. Here's some photos from repeat photography from 1925 to 2013. You can see these big open conditions, these big trees with open conditions. But because fire was turned off and because there's a fire deficit, a lot of other trees started growing. And then in 2012, a fire occurred and basically killed all of the trees. So we have effectively removed the low severity fire regime from Western US forests because our forests have grown so much and have so much biomass on them due to the fire deficit. We've moved dry forests from a high frequency, low severity condition to a high severity, low frequency condition. Here's another example of some repeat photography I want to show you in Colorado. In 1896, fairly open forest conditions, fire got turned off and a lot more trees grew. And then the inevitable fire occurred and it killed all or most of the trees. It was a stand replacing fire. And so now the landscape looks like this. So why am I focusing so much on dry forests? I want to explain why dry forests are so important in the Western US. And here's a very simplified profile of our forests or our vegetation in the Western US. At the very lowest elevations, we have grassland and shrubland. It's basically too hot and dry to support trees. On the other end, we have alpine and barren conditions and rocky conditions, and it's too cold to support trees. And in the middle, we have our forested zones. And down here at the bottom is our dry forest condition, our dry forest type that historically had frequent low severity fire. And because this has basically been reduced the amount of fire here, and we're seeing more and more stand replacing fire, we're eroding the dry conifer forest. Dry conifer forest is also at the edge of this area, this climate that's too hot and dry to support trees. So under a warming climate, it's becoming way more difficult for dry conifer forest to recover back to forest after a fire. And we're starting to see the dry conifer forest getting eroded by stand replacing fire. So here's a little cartoon kind of just showing that. We're seeing the dry conifer forest disappear due to stand replacing fire. And we're seeing this in the real world. There's increasing evidence all over the place in the Western US that these high severity fires are resulting in conversions from forest to non-forest. So why is that? There's a couple of reasons that are important to point out here. First of all, a live tree is oftentimes necessary to provide seeds so that a site can return to forest. And the farther a burn site has a high severity fire, the farther it is away from a live tree, the less likely it is to recover to forest. Meaning that if a site is beyond, say, 150 or 200 meters from a live tree, it's very difficult from a seed to get from the live tree to the middle of a patch of high severity fire. And so it's more high severity patches and stand replacing patches we have out on the landscape, and the larger they are, the less likely it is we're going to see recovery back to forest. The second thing that's going on here is that the climate is becoming increasingly unfavorable to seedling establishment and survival. So even if a seed is present, it's more difficult for the seeds to establish. And the reason why is that seedlings have thinner bark and much shallower roots. So the warmer and drier conditions that we're seeing as a result of climate change is killing the seedlings even if they sprout. It's a climate change double whammy here. We're seeing more high severity fire as a result of climate change, which means that more and more area is too far away from a seed to recover back to forest. And then even if a seed is present, those seeds are having more and more difficult time having the seedlings survive and turn into adult trees. So a lot of what I've shown is kind of doom and gloom. So I do want to end on some positive notes or ways to move forward. And I do want to talk about lessons from the wilderness. Wilderness areas in the United States are a form of protected area. They're a form of protected area in the United States that is the highest form of protection. And in a handful of wilderness areas, fires are actually allowed to burn. Fires are not put out all the time. And one of these wilderness areas is the Gila Wilderness in New Mexico. And the Gila Wilderness in New Mexico is a great example of a dry conifer forest that has maintained its frequent fire, low severity fire regime. Here on the left is a photo from 2012. It was taken 1 year after a 2011 fire. And over on the right are some aerial photos taken from an airplane or from a satellite from 2019. And they have burned a lot previously, but there's still trees present. This guy right here burned in 1993, 2003, 2012, and 2016. So it burned 4 times, and there are still a lot of trees on the site. At the top right, it burned in 1993 and 2005, and there's still a lot of trees on the site. On the bottom right, it burned in 1985, 1993, 2006, and 2012, and we still have trees on the site. So there are select examples of the low severity frequent fire regime occurring, and I think that does just help us understand how we can move forward in keeping our forests, maintaining our forests in the future, even as the climate is warming. I do want to show another example from the Gila Wilderness because it just experienced a fire. In 2021, the Johnson Fire burned. It's shown here in red. The perimeter of the fire is shown in red. And on this bottom left map, it's showing the fire history, or how many times it previously burned. You can again see that it's burned a lot. And if you look at photos before the Johnson Fire and after the Johnson Fire, almost everywhere where there were trees before the fire, there were also trees after the fire. There are a couple examples that I'm not showing where there was some stand replacing fire in the Johnson Fire. For the most part, where there were trees before the fire, there were also trees after the fire. And I believe it's because we've maintained the frequent fire, low severity fire regime that's native to this forest type in this area. And, realizing that we can't allow fires to burn all the time and all the place because we have communities and infrastructure and people, there's other things we can do or other actions we can take to help our forests survive that inevitable fire. So I think just realizing that fire is inevitable outcome, we need to be preparing our forests for that inevitable fire. And there are tools we have like prescribed fire. Here's a photo of prescribed fire on the left. We can also couple prescribed fire with treatments where people go in with saws and take out small trees and restore the forest to conditions that can survive that inevitable fire. So we might not be able to restore fire or a low severity frequent fire system to these dry forests, but we can restore conditions. We do have the ability to mimic the effects of fire through treatments and prescribed fire to set our forests up for that inevitable fire. So this forest over here at the bottom right looks like it has had frequent low severity fire, but it hasn't, but it's still set up for that inevitable fire. So when that inevitable fire occurs, it's less likely to burn at stand replacing severity. Thank you all.
Sean, thank you very much for a great presentation. I know I learned quite a bit about fire regimes and severity and climate change.
You talk about the Johnson Fire. Is that like a significant fire that happens in an area, and why is it important for you to use it as an example here?
Well, I used the Johnson Fire. So the Johnson Fire is the name of the fire. And I use that as an example just because it was a fairly large fire that burned this year. And the effects of that fire are different than a lot of the other fires we're seeing. The effects of that fire on the trees were different, meaning that was mostly a low severity fire. But a lot of the other fires we're seeing are these stand replacing and high severity fires. So I just think that Johnson Fire that occurred in the Gila Wilderness is a great example of how the landscape was set up to survive fire, and it was set up to not experience those stand replacing effects.
I had a question related to kind of the same thing right there. You mentioned in the Gila Wilderness that the Johnson Fire, that most of it was not stand replacing, but then there was like a very small section down in that southwest corner that had a little bit of stand replacing. But if I'm understanding right, even though that was like a stand replacing event for that small area, it probably has a chance to maybe recover just because there are seedling sources nearby, unlike the other places where it's like really far away, just because of its healthy history.
Well, correct, because the patches of stand replacing fire are smaller there, it does have a chance to recover back to a forest type. But again, there's concern that even if trees are present, our climate's becoming less and less conducive to seedling survival.
Just one more question on the Gila Wilderness fires. Most of those fires were natural causes, and I suppose lightning strikes. Is that right?
Most of those are lightning ignited fires, correct.
I have a question towards the beginning of the presentation that you showed us a drought indication from 600 years ago or more. You can see the drought in above zero or below zero. How did you guys find out about that? Is this through the technology we talked about last time?
Dendrochronology.
That's right. That's the one. Is that how you can determine which year you can get a drought and which you don't?
Yes, it's amazing how much we can learn from tree rings. And we as a scientific community, not me personally, but we as a scientific community have been able to reconstruct climate through time based on the widths of tree rings. For example, especially in dry areas, the widths of the tree rings are extremely small. That's a drought year. And if you have a lot of growth, that's a non-drought year or a wetter year. So we can reconstruct climate based on tree rings.
Sean, I have a question about indigenous folks prior to 1880 when they burned quite a bit. Are there any studies at all about how much they burned or where they burned or how it affected the fire regimes of today?
Well, we're learning more and more about that. It's actually a very important research topic that's gaining a lot of interest right now. So we don't really know the answer to that. We do know that in California, there was a lot of burning by humans. I don't think we can put a number on it quite yet, but it was a lot. In some places, also highly localized. I'm going to give an example from the Boundary Waters Canoe area, which isn't the Western US, but it still is a great example. In the Boundary Water Canoes area, there was a recent study that looked at, again, fire-scarred trees to figure out where fires burned. And they measured the fire-scarred trees along known travel routes and off of known travel routes. And they saw a lot more fire on the known travel routes than off the known travel routes. So the interpretation there is that humans started a lot of fires along those known travel routes.
In the past, have you guys ever seen scales of extreme fires that we have nowadays in the history? And if we have, could you actually see how long it takes the area to recover back to the forest? Or it just doesn't happen, like it doesn't go back to the past condition?
So we can't really at this stage go back and say that fires are X, like a certain size. But we can infer that there was a lot more fire. I had some slides in here that I took out to shorten my presentation that showed the number of sites in the Pacific Northwest that experienced fire every year. And it's an incredible amount based on fire scar data. So we can't put a number on annual area burned in the past, but we can confidently say there was a lot more fire. But again, there's really not the issue of recovery that you're asking about, because those fires, by definition, are not stand replacing fire, or else the trees wouldn't be there to record the fire. Just the fact that the tree survived the fire, left a mark, and told us what year the fire burned, and continued to live, and then burned again and left a mark, and then continued to live, is very strong evidence that those fires were not stand replacing fire. So fire was actually maintaining the forest. So the forest didn't really need to recover. The fires actually helped the forest stay as forest, because it would kill the small trees and the underbrush without killing the larger trees.
You had mentioned that when there's a lack of a seed source, obviously there's not much of an opportunity for seedlings to get established. And then if there is a seed source and a seedling is established, that sometimes it might struggle just because the conditions have changed, because of the warmer conditions and drier conditions. But are you familiar at all as far as like if nurseries are growing seedlings and getting them to a point where they're a little bit older, and then with planting programs, has there still been less of a success with planting just because of the warmer, drier conditions?
Anecdotally, there have been a lot of failures in planting because of the warmer and drier conditions, but there are methods or tools that greenhouses can implement to improve success of these plantings. For example, the greenhouses can do something called hardening the plant, where they make it a little bit dry but don't kill the tree, and then they might do that again, and it kind of toughens up the seedling, and it becomes more used to the drought conditions, and then that can be planted. Another thing that can be done is there's different phenotypes or variability even within species. Some ponderosa pine trees, for example, ponderosa pines in Arizona and New Mexico are a little more resilient to drought than, say, the ponderosa pines in Montana. So the greenhouses are starting to think about, and the people who are planting are starting to think about maybe using trees with certain genes, even within the same species, that are more likely to survive under these warmer and drier conditions.
When I was a fire crew back in the 70s, if we had a 10,000 acre fire, I mean, that was a mega fire. That was what we would call a project fire, and we'd bring people in from outside just to fight that fire that was 10,000 acres. And today, these mega fires are going 100,000 acres sometimes. Do you have any record about what the cause of these mega fires are? Are they man-caused fires mostly? Are they lightning strikes? A combination? Do you have any data on that?
There are data on that. I don't have it at my fingertips. I could just tell you that as a general rule of in the Northern Rockies, like in Montana, most of the large fires are ignited by lightning. In Southern California, most of the large fires are ignited by humans.
Mm-hmm.
In the Sierra Nevada, I believe it's about half and half by humans, half by lightning. So it really depends where you are geographically.
You talked about the fire deficit. Now, with the fire management methods, we have made several videos here, and we've been talking about the importance of prescribed fires. And you also mentioned before 1800, when the indigenous people would regularly set fires. Either they know that's how it could help the forest, or they do that for their own benefits. Either way, what's the modern prescribed fire similar or different from the way the indigenous people executed?
We as an agency and a society are now doing prescribed fire for the sole purpose of fuels reduction and to make the community safer and to make our forests more resilient to that inevitable fire. The traditional fire or cultural fire used by the indigenous people, they may have lit fire to do that as well, to protect themselves and communities, but they also lit fires for other cultural reasons, like for enhancing habitat for game species like deer and elk, or they would light fires to stimulate the growth of different foods that they ate. So the difference is the reason why they might light the fire. The outcome might be very similar or the same, effectively, in terms of frequent low severity fire or setting up the forest to conditions that are more resilient to that inevitable fire.
You talked about the fire deficit. Does it make sense that you would try to do as many as prescribed fire to deduct the fire deficit, if that's the correct way to say? And if so, do you have roughly like a number, how much more you guys will have to do that? Are you guys doing close to what you wish you could, or is it still a far way to go?
Yeah, that's a good question. We are doing nowhere near the amount of prescribed fire or other treatments necessary to restore our forest to conditions that can survive that inevitable fire. The estimates I've heard are about we need to do 10 to 100 times more prescribed fire than we're doing now. And it's probably more on that upper estimate of 100 times more. So there's a lot of work to do.
What does this mean for land managers moving forward as far as the Forest Service and other agencies that manage the forests in the West?
It means a few things. First of all, that our forests are in danger, they're in peril. I'm not only a Forest Service employee, but I love the forest for recreation. I fish and hunt and hike with my family in the forest. And so I really want to see forests succeed and survive into the future. So from the management perspective, I think the first thing to realize is that fire is inevitable. And I feel like us as a society, we're more reactive to the fire. A fire starts, we fight it. After the fire, we go out there and we plant a bunch of trees. But if we flip it around and be like, all right, the fire is going to happen, let's do something before the fire happens so that it's a low severity fire, then a lot of those reactive fire approaches or post-fire vegetation management actions might not even be necessary. It's like save what we have instead of try to restore what we had, I think is something that I think is important, because it's going to be incredibly hard to bring some of these areas back to forest. But we still do have a lot of forest. So from a land manager's perspective, it's like, let's save that forest and make sure it does not have or experience stand replacing fire when that fire occurs.
From what I'm hearing, it's not just one treatment. There's places where you go in and to get it back to that natural state or close to as you can. It's more like thinning and prescribed fire. It's not just one tool. It seems like it's going to be multiple tools and working across agencies to accomplish it.
Yep, multiple tools. Thinning and prescribed fire are considered the most effective, but also realizing that it's not a one and done deal. Like it's going to continue to grow after that. So there needs to be maintenance treatments, whether it's maintenance prescribed fires or something else, but we need to go in every several years to maintain it, or else if you don't, then it just keeps growing and we're back in the same place.
Is there anything that regular people could do to help this situation? Let's say if we can tell people in the west of the USA, there's something they can do. Like you said, the 2020 might become the new normal in the future. Is there something they can do to prevent that or slow it down or make it better?
Yeah, of course, reducing fossil fuel emissions is key. That's probably takes more governments to get involved than individuals to make big institutional changes. I think that instead of what can we do to prevent climate change or prevent more fire, I think it's more about what can we do to help the land management agencies achieve their goals in making our forests more resilient to fire, like accepting smoke from prescribed fires. For example, there's a lot of organizations or people or groups who are opposed to a lot of the actions that land managers take to try to restore our forests. Prescribed fire being one of them, just because of smoke or because of the threat of the prescribed fire escaping. But these are basically some things that we're going to have to deal with if we want to have our forests survive into the future. So I guess what regular people can do is just to be a little more patient or a little more accepting of smoke, say, for example, and also maybe learn about the forests in your area and be more accepting of what the land managers are trying to do to increase the resilience or resistance of these forests to the inevitable fire.
Your presentation focused a lot on the lower altitude and dry conifer forest. They have more frequent fires in the past, but for the colder areas with higher altitude forest, they usually don't have that many forest fires, and when it happens, usually will become bigger fires. What's the reason there? Is it because it's colder, so it doesn't have that many fires, and therefore there are more biomass help the extreme fires there?
Yeah, you basically answered your own question. In those more moist areas and colder areas, the average year isn't conducive to fires. And so only in extremely dry years are fires actually able to burn. And so just the frequency of fire conducive conditions is a lot less in those colder and moister forests. And so that allows the biomass to build up. And so when that inevitable fire occurs, it tends to be a stand replacing fire. And in contrast, in the warmer and drier forests, the frequency of fire conducive conditions is much more frequent, like every year or every 2 years or every 3 years versus say every 20 years or every 40 years.
Then is it fair to say that with the climate change, these cold, more moist areas, they might become drier and with higher temperatures, which will lead to more frequent extreme fires for them too?
It's very fair to say that. And there's been some recent scientific studies that have concluded that we're seeing more fire in these very high elevation, cold forests because of climate change.
You talk about how there's lower elevation species like the ponderosa pine, and then you go higher, and that gets into like the spruce fir, lodgepole, the different species at different elevations. And so are you finding it all that with like the warmer, drier conditions, like our ponderosas kind of creeping up in elevation as far as like it's becoming more adaptable, or is it changing at all as far as when fires come in and it's changing the landscape, and then on top of the whole reseedling process and the drier condition?
Yeah, that's a great question. And there is some recent scientific evidence that different tree species are actually moving in response to climate change. They're, moving up in elevation or northward to cope with climate change. One of the issues or concerns is that, trees can only move so fast because they've got roots, and so their seeds only move so far, and then they have to grow, and then they have to get to reproductive age before they produce seeds again. So the concern is that the climate is moving or changing faster than trees can actually move. But there is evidence that tree species are moving in response to climate change.
Well, I would like to thank Sean for your presentation. It was very, very well presented. I hope if you're viewing this video that you'll check the websites of both the International Wood Culture Society and the Rocky Mountain Research Station, because we will be posting this video as well as other videos concerning fire in the West on these websites. Thank you very much for your participation today.